right. Hi, everybody. We'll go ahead and get started. So you can have a few more folks trickling in. Thank you all so much for coming. My name is Rachel Whaley. Very excited to be here teaching you all about SQL and Python for the month of April. A little bit about me and why I'm here teaching this class. I've been working in data for the last 9 years or so in a variety of different fields in nonprofit, consulting company with media companies, public sector, briefly here at USC. Actually, I worked at Annenberg on the database schools of staff use, and then I now work at a podcasting technology startup. LA. So I've been working with data, Python and SQL specifically for a long time. And yeah, excited to be teaching this class. I think the difference that you'll find between this class and any sort of like learn SQL online or YouTube videos or something like that is I'm going to try to focus pretty specifically on how you might actually use it in a role day to day. Obviously, I work in the podcasting industry, so we're going to use examples from that. We're going to use examples from just the media space in general, just so you can start to think about ways that these tools might apply specifically to some of the paths y'all might be interested in, and just sort of the working world. So that's me. Since we're not a huge group, I would love if we could maybe just do a quick go around, just tell me your first name and what program you're in, and maybe what you're hoping to get out of this workshop. That'd be cool. Okay, great. Let's see.
Hi everyone, I'm Ali. I'm a first year master's student in communication management, and I'm interested in SQL specifically. I started learning it a while back, and I didn't get very far in my online course, so I'm interested in getting into it.
Okay, great. Maybe let's go back to this job.
Yeah, this year, students. And use SQL before, but not so
okay, great. Sounds good.
Well, I'm Twinkle. I'm a first year master's student doing the digital social media development. I know nothing about SQL, but I'm more in the UX design field. Hopefully this will help me with like data analytics for UX as well.
Perfect. Thanks, Uncle. Yeah, a lot of overlap with the UX space, so great. Yeah, maybe let's come over here.
Hi, I'm Zimu, and I'm also a first year graduate student in communication management.
Okay.
For this workshop, I'm particularly interested in SQL as well. I actually had a very bad experience learning Python during my undergraduate.
Oh no! All right. Cool. Well, this will definitely not be a bad experience. Hopefully, we can bring it back from that. And your name, it was Zimu? Is that? Okay, great. Thank you. Hi.
My name is Ruby. I'm also a first year CMGT student. Yeah, and I think I don't have any prior experience to both of it, so I'm looking forward to it.
Great. Glad to see you again. Go ahead.
Hello everyone, my name is Mansi and I'm a second year graduate student in communication management, and I have some experience in SQL, nothing in Python, and I think in this age where technology is used everywhere, I think it's about time that I kind of get on the bandwagon.
Very good. That's a smart idea. All right. Thanks. Nice to meet you, Mansi. All right.
So, hi, my name is Lydia, and my undergraduate school, I studied a little bit about Python, but just basic. I have no experience on SQL, but I'm also a second year student in computer management, and I'm going to graduate next month.
Nice. Congratulations. All right. Nice to meet you, Lydia. Thanks for joining us in your last month of school here. And then in the back.
Hi, my name is Shruti. I'm a second year journalism major, and I don't have experience with this.
Cool. You're in the right place. Great. Well, thank you all so much for being here. So this class should work pretty well if you have already learned some SQL. I'm going to try to introduce various different parts of the language. So if you already know how to write simple queries or you've already seen those before, we'll dive into a little bit more of the ways you can get a little bit more advanced with it. If this is totally new to you, if you've never done this, if you're not sure if it's SQL or SQL or what that's about, that's totally fine. You're also in the right place. We'll start from scratch. And the tool that we're going to use for this will kind of help. It'll be a good tool if you're a beginner in particular. We won't have to do any sort of like complicated computer setup that you might have had in other coding classes. It'll be all in your browser, very simple to get started. Okay, so the format of the way that today is going to work, and also the subsequent sessions this month, if you're going to join us for those, is it's going to be pretty hands-on. So I'm going to present some slides, I'm going to talk about some concepts, but we're going to kind of cycle through me doing a little bit of that, and then you all actually doing, writing some queries, getting your hands on the keyboard, and doing it yourself. So just be ready for that. This is definitely not a sort of sleep in the back kind of class format. And so to do that, if I can get my arrow keys working, we are going to be using a tool called Hex, which is if you've ever used any sort of notebook tool for SQL or Python before, if you've learned that in other classes, you might have used something called a Jupyter notebook is pretty common. Hex is basically a version of that also works with SQL and is much easier to use because it's a nice browser-based thing. I reached out to Hex and they very generously offered their like pro plan version of their software for you all, which is very exciting. So to get to that, which you should do for this class, you want to type in this link shortcut that'll take you to Hex, website called hex.tech, which is where their platform is hosted. And if you go there and sign in with your USC email address, that'll get you activated on the platform. It's a free account, so don't worry about any of that. But if you all want to take a moment to do that, just get logged in. You don't have to do anything else right at the moment, but we'll be using that throughout today as well as the rest of the sessions in this series. All right, maybe just flash me a quick thumbs up if you get that to work. Cool, we'll give everybody one more moment and we will dive in. Yeah.
So it's like asking if I would like to use Hex and it's great also, like similar to big SQL plus Python for that.
Oh, yeah. You can just leave it on that screen. It is, you can put SQL and Python. That doesn't actually change anything. It's just a little preference. Yeah, okay, cool. All right, I'm gonna keep going, but if you still need the link, it's in the middle there. Okay, so just quick introduction to what is SQL. You can pronounce it SQL, you can pronounce it SQL if you talk about it a lot, which I do, not everyone does. It's a little faster to say SQL, so that's what I prefer, but both are fine. What does that stand for? That stands for Structured Query Language. Basically, all that means is it's a tool for interacting with a database. What is a database? A database you can think of as any sort of structured collection of data. The most common database, the most simple database that I think everyone in here has probably used at some point is a spreadsheet. So you can think of any database, if you're trying to picture it in your mind, picture it as an Excel spreadsheet. So any table in your database is just going to be, you know, what a spreadsheet looks like on your computer screen. Your rows of data are going to be the individual items in your database, and then your columns are going to be the fields in your database. All right, so if you have a form, you fill out fields on the form, it spits it out to a Google Sheet. Maybe a lot of you have interacted with that. That's exactly how you can think of a database. So databases are used for literally everything. I went back and looked at a slide from my databases class in my master's in computer science program, which was several years ago now, and we had a list of all the industries that used databases, and I started typing it in here because I thought it might be useful, and then I realized that that's silly in 2024 because everything, literally everything uses databases. But yeah, any industry you could think of, any corner of media, social media, anyone using social media, I mean, it's truly everywhere. And so SQL is a great place. If you've never done any programming before, it's a really great programming language to start with. If anybody ever wants to learn coding from scratch, I always suggest they start with SQL because it's a very simple language at its core. And if you've ever used a spreadsheet or anything like that, a lot of those concepts will transfer over really easily. So you'll have a bit of an easier time getting started. All right, so who uses SQL? I think a couple of you touched on this in the intros. Maybe you're interested in the tech industry or just feels like everybody knows how to code, and so you want to know a little bit. What's great about SQL is if you know a tiny bit, you are like way far ahead of people who don't know any at all. So just knowing a little bit can be really, really valuable. I work at a tech startup, so we're a company of about 20 people. We've got like 4 software engineers and the rest of us, and then me, who's, you know, does a little bit of this stuff. And then everybody else is pretty non-technical. The entire company has access to our SQL database, which has every piece of information about our entire technology platform. So anybody in the company can come in and write SQL queries and figure out, you know, what was our revenue last quarter? What are our top selling shows? What are the, you know, ad deals we have going on right now? Any piece of operational information you might need in a non-technical role like that, you can access through SQL. That's very common at tech companies. So if anyone has any interest in working in that kind of industry, knowing a little bit of SQL is a great asset, whether you're in a technical role or not. Also, a lot of other companies are starting to get, as their sort of systems get more updated, a lot of modern day kind of database technologies. You can interact with them with SQL. If anyone here has ever interacted with a Salesforce database, for example, there's sort of a flavor of SQL you can use to extract data from Salesforce databases and many other kind of big enterprise software platforms. So it's a great thing to know kind of wherever you're planning to go. Knowing just a tiny bit is a really, really good place to get started. Okay, so what can we do with a SQL query? So we know we can interact with a database, but what does it actually do? The most kind of common way I explain this to people is that if you need data that meets certain criteria, you need information that meets certain criteria, that's where SQL query is going to be your friend. So any sort of the who, what, where, when, why type of questions that you might have about your data, SQL is going to be the tool that you can use to get an answer really quickly. A lot of SQL queries can be written in just a few lines, so you're not like writing pages and pages of code to get what you need, which is what makes it really powerful. So these are some examples of the types of questions you can answer with SQL. How many episodes in this list of episodes have a certain word in the title, for example? We can also do some summarization with some basic functions. So things like how many, averages, basic math. So, you know, we've got a list of all the episodes in all the seasons. How many episodes are in each season? That's a very simple roll-up that we could do with SQL. If you've used Excel and you know pivot tables, that's a kind of roll-up you could do in a pivot table. Same idea here. We can do a summary. We can also do some manipulation of data, right? So let's say maybe you have a spreadsheet and you have all the ratings of a show, but you really just want a column that says, okay, good if the rating's above 8 and bad otherwise. You know, I've got a very black and white situation that I want to categorize. That's the kind of thing you can do programmatically in SQL. Instead of going through your spreadsheet and typing good in every row where there's a high rating, we can actually just write a little bit of logic that says if greater than 8, good, else bad. And so SQL allows us to do some stuff like that, which can eliminate a lot of manual work. We can also group data. So maybe we have data about many shows, many seasons of many shows that all have many episodes. So we could group our how many episodes by show and by season, right? So we could do some kind of multiple layer grouping or summarization. And we can also combine data. This is super, super powerful. If you're going anywhere related to the tech industry, most records in a data set will have sort of a unique identifier. If you're thinking a database of people, it might be their email address, right? So you might have a database of all your customers, and every time they've subscribed to the streaming service, say by email, and then you might have another data set that's got all your customers' emails and maybe the last time they opened a marketing message from you, right? Those are 2 different data sets, 2 different spreadsheets that you have. With SQL, you can join those 2 things together because they have that overlapping column. They have that email address column. You can use tools in SQL to put those things together and say, all right, of the people who opened our last marketing email, how many of them subscribed to our service? You can see how that could be really powerful to combine data sources. So we'll touch on how to do all of these things today and over the course of this series. Okay, let's talk a little bit about this tool we're going to use, which is Hex. So as I mentioned before, Hex is a SQL and Python notebook tool. So the way that it works is it will allow you to write little bits of Python or bits of SQL, access the results of those, and then write more Python or SQL to kind of further manipulate what you've done so far. This is really great because much like any math class you've ever taken, it's usually good to kind of show your work, right? To do each individual step individually, kind of be able to check, okay, I'm going to add a column that counts up all my episodes. I want to make sure that looks right before I further manipulate it, maybe with some Python code that we'll write in a future week. I want to make sure that's right. So this sort of concept of cells I find is really helpful, not only for learning, but I use this every day in my own work at my job. So also thought it'd be a helpful tool for you all to learn because of that. So here's an example of how some cells could work, right? You could write a simple Python function to load your data. We'll talk about this sort of thing next week. Then you can write some SQL queries to join your data together. Maybe you've got a few different data sets that you want to bring together, like the email address example I mentioned. Then you can write some more Python, maybe do some text analysis, something like that. And then it's also got some built-in visualization tools. So things like creating charts, graphics, all of that. And this is similar to what you would find in sort of basic versions of Tableau or Google Analytics or anything like that. So if you've ever played with any sort of like out of the box visualization tool, this is very similar, and it's very powerful to have these three things all together. So hopefully this will be kind of a fun thing for you all to know about. Okay, so the very first thing that we're going to do is just some basic Hex setup. So once you've logged into that link that I mentioned, it might give you some pop-up messages that are sort of like welcome. You can kind of like click through or X out of those. And then you're going to want to go to where it says projects on your Hex screen. So let me share mine here. That's where I was inviting you guys. Okay, so on the left-hand side, you should have projects, something like this. And you're going to want to look for the one that says week 1 intro to SQL. If you hit the ... here, it'll allow you to duplicate. So make sure you're duplicating and making your own copy, because what you're going to do is be writing a lot of your own code in this project. So if you don't see the project in the middle, make sure you hit projects on the left-hand side, and then you should see one in there that's called Intro to SQL. So go ahead and grab that one and hit duplicate. Yeah, for sure. So if you're logged into the link from the beginning, if you want to click on projects on the left, and then you should see a list of projects in the middle. You should see one that says week 1 intro to SQL. Perfect. That's great. So that intro to SQL one, you want to do the ... and then hit duplicate. Awesome. So once I duplicate it, I should get to a screen that looks like this. This will say copy of, something like that. Yes, you can close it. We're actually going to talk about that in a little bit. But you can close it for now. Yes. So any pop-ups that you get, you can close. And then you can give this a name. So I'm going to say, just give my name Rachel week 1, and this is going to be my workspace where I'm working. Okay. Yeah. Ooh, okay. Okay. You just already put the note on it, which is fine. Perfect. Everybody else good? Everybody have something like this open? All right, sweet. Okay. So just to give you a quick intro to how this works. In the middle, this is where you have your cells that I was talking about. So I have one pre-written cell in here for you guys, which is called, which is just a Python cell. We're not going to talk about this code this week. We're going to talk about Python next week, but I am using it to run or to load our data. So you're going to come in here, when you have a cell, you're going to need to run the cell. So writing the query doesn't mean that actually anything's actually happened with the data. You're going to have to run it. We'll do this as we write each SQL query. But in order to run a cell, you're going to hit the run button, which is right here. You can also hit run all at the top. It's those little pink triangles. So I'm just going to hit run, and it'll give me a little sort of like wheel of dots to make sure that I know that it's running. All right. Cool, the dots go away. That means it's run. This particular bit of Python code isn't like printing anything out, so it's not going to show, but if it were a query, it would show its results right underneath. We'll talk about that in a second. The other reason I love this tool, if you look at the top, there's two sort of toggles. One says Notebook, one says App Builder. If you hop over to the App Builder section, this is the same view of something else that we just saw. So I put a little silly GIF in here because our topic, sort of data topic for today is going to be data about the TV show Seinfeld. So that's what we're going to use for today's exercise. So you'll notice here that my silly little GIF is showing up, but my Python query is not. This is cool. This essentially allows you to create a second view of your same project where you can kind of hide the like queries that you wrote and just create sort of a presentation report version without having to like copy paste everything you did to a PowerPoint slide. Make sense? So I think this is really cool. It's super fun. I make these at work all the time. I made 2 today for various reports and trackers and things that we need. Yeah.
Can you dim the lights?
Yeah, of course.
Oh, that better. Cool. Thank you.
Okay. Fantastic. Cool. So I'm going to go back over to my notebook section. In addition to having code cells, so you can add a cell down here. We'll talk, Magic is their AI thing. We're going to talk about that in a little bit later. But you can add a Python cell. You can add a SQL cell. That's mostly what we'll be doing today. You can also add a bunch of other types of cells. Something that I like to do is add text cells in between things, and I can just like make notes to myself. Those are great also for when you go to create your app. You can choose to include some text over on this view to sort of explain to your end users maybe what you're doing in your queries. So it's kind of cool. Even just today in the class, you can add text cells if you want to just sort of take some notes for yourself. That is an option there as well. You can also delete any cells. So I'm going to delete my little silly GIF, for example. So you can just hit the ... to the right of any and hit delete. And that's just going to delete that one cell there. Okay. No, you can totally leave it. If you'd want to sort of hide it, you can also use a little arrow to sort of hide. Totally up to you. All right, so the next sort of concept to know is sort of what data you have in your workspace. So in this case, all I'm doing is I've taken in 2 data sets from 2 different sources. Again, we'll talk about how this code works next week. But you'll notice my little pop-up down here has given me 2 little green pieces of sort of data tables is what it's generated. So one is called transcripts data. So that's going to be the transcripts of these episodes is our data set. And then this is going to be ratings data, which is the data, the sort of ratings data from IMDb about each episode. Okay. It's just a quick little intro. I think I'm going to pause there on Hex and go back to the slides for a moment. Okay, great. So everybody's in your project. You have a copy of something that looks like this. Sounds good. Okay, fantastic. All right. So let's talk about writing a query. So this is the basic structure of a query. This looks like a lot of things, but the top 2 are in bold because you only actually need the top 2 for your query to work. All of these you may or may not include depending on the type of criteria or what exactly you're trying to extract from your data. So very first thing that we're going to do is if we think about, maybe think about a spreadsheet, right? Picture a spreadsheet in your mind. What are we going to select? You're selecting which columns of your spreadsheet you're going to grab. If you want all the columns of your spreadsheet, you do an asterisk, and that'll just select all the columns. So you might be select star is how you pronounce that. So I might say select star, or I might say, you know, select season number, episode number, and character name, for example. Okay, and then from, that's my table name that I am selecting from. So in our little example that we have set up, our little data template, we had our ratings data and our transcripts data. So I would either say from ratings data or from transcripts data there, and that's how I'll know what I'm pulling it from. These are other terms we'll come back to. These are how you can do the other things that I mentioned in the table previously about if I want to summarize, I could group by my data. So I could say I want to summarize everything by episode number. So I could do a group by, I can order by, same thing. So that's just like sorting anything in Excel. I could sort by season number maybe. If you only want, say, the top 10 episodes by rating, you can limit to say a specific number of rows, limit my top 10, my top 100. That's where I'm going to be applying filters to my data. So maybe I want to select all information about episodes from season 5. I could do where season equals 5. That's how I would get my season. And then join is how I would join multiple data sets together. So this idea of if we had all of our customer emails over here and then some other piece of information about our customers that also had their email addresses, we would use join. So if you've ever tried to learn any other programming language, or maybe if you've tried to learn SQL before, you'll notice that these words are like pretty straightforward, right? Like the word is what it's doing. It's like weird robot English, but it is like closer to English than a lot of programming languages. This is one of the reasons I love to start with this, because when you think in your mind, okay, I want to summarize all the information by episode, to get from that to a SQL query, the final query actually looks pretty close to whatever original thought that you had. So it removes a little bit of the translation layer that a lot of programming languages have, so it can be a great one to start with. Something else I'll just mention, it is sort of a convention in SQL to write these words in all caps and write the other words in all, like any column names or stuff like that, in lowercase. You don't have to write them in all caps. I often don't. You just might see that if you're looking at SQL stuff online. Totally up to you. All right. Okay, so we're gonna try writing your first query. Okay, so I'm going to talk about this and then I'm going to demo so you guys can kind of do it along with. So what we're going to do to write our first query is we're going to add a SQL cell to our hex project. So that's where we're adding a cell underneath. This little icon that sort of looks like a bunch of Oreos stacked together, that's sort of like the universal symbol for like a database. So that's how you can remember that SQL is basically cookies. And then we're going to write a very simple query. Okay, so the table or the query that we're going to write is going to look like this: select star. So asterisk is going to select all the columns. So we don't even have to worry about what the columns are called. We're going to select star, and then we're going to do from table name. So as I mentioned, we have 2 tables, dealer's choice. You guys can select from either table. From our table, and we're going to limit 10. So that limit 10 just means we'll only return the first 10 rows of our data set, just so we can start to see what's even in here. What does this data set look like? Okay. So you're going to type that in your cell, and then we're going to hit that run button. So the pink triangle on the side. I'm going to pause there. We'll do that, and then we'll come back to this next one. So to do a little demonstration of this, you're in your SQL cell here. I'm going to do SQL cell. I'm going to type my command. So I'm going to do select star from, and I'm going to say ratings data. Now, the first time you type in a query in a hex, what you're going to want to do is make sure you've grabbed the right data source. In this case, when I do select source over here, I see my data frames. I see these 2 transcripts, rating data. That's the one I want to select. 3 data frames. Here, you can do more complex setups where you like connect to multiple databases. But in this case, this first one you want to select and just hit data frames. All right. So I'm connected to data frames over here. I'm going to do select star from ratings data, and I'm going to do my limit 10, just like that. So it's just spaces in between, no like complicated lines or anything. And then I'm going to hit run. So my little pink triangle, or I could hit this run up top. I'm just going to hit this one. It's going to think for a second, and then it's going to spit out its results right below. So you should get something popping up right here once you hit run. If you don't get that, let me know. Yeah. Yes, exactly. A space between each word. You can actually also put new lines if you like. So as we start writing longer queries, you'll see I might do it like this. But if I run that, that runs exactly the same way. Oh, of course, I deleted my L, so I sort of defeated my own example there. But yes.
So it won't work if you don't.
Correct. Yeah. So if I don't include spaces, let's see, do my star, remove my space. If I try to run it, then it's not really going to know what's up, and it'll give you a little visual clue because the words won't light up the same way.
If that's for the table, like it's not in parentheses,
Exactly. Yep. You just put it right by yourself or right by itself, and just remember to spell it exactly the same way. So it's got the underscore in between. Yep. Another keyboard shortcut kind of thing, as we keep going through here, you can hit the pink run button each time you edit. You can also hit Command Enter on your keyboard, which is what I usually do, to just run it real quick.
So basically what this implies is that from the ratings data set, whatever is in terms of ratings limited to 10, that means not exceeding 10 is what the answer is.
Yes, exactly. Or yeah, so limit 10 meaning 10 rows. This is the number of rows of our data set. So our data set might have thousands and thousands of rows. This is saying I'm just going to return the first 10 rows. Yeah, it doesn't have to do with like what the rating actually is. That's a different filter. We'll talk about that a little bit later. Okay, good questions. So the reason that you write a simple query like this, you write a query like this almost every time you start with a new data set or a new SQL project, because something simple like this just lets you see with your eyeballs what the data actually looks like. So you might be starting in a situation where someone gives you a spreadsheet and you sort of upload it to Hex to use in with SQL queries. In that case, you've already seen the data. In many cases, you're just sort of using a database connection and you haven't seen it before. So you write a very simple query like this, select star from table, so that you can see what our data actually looks like. So let's look at this first row, for example. Here's the first row of our data set. This first column is just giving me a little row number so I can sort of visualize it in my mind. But here's my data. So I've got my season number. These first few are season 1. The first season of Seinfeld only had a few episodes, so it makes sense. We get to season 2, title. Okay, stakeout, the robbery. All right, these all look like kind of TV episode titles. It makes sense to me. Air date. So here we've got the air date. It looks like the dates are formatted like kind of funky. I don't know why you would abbreviate July with a period when it's 4 letters. I don't know. That's a separate problem. Okay, so we've got a little bit of like funky formatting, but that's our air date. Makes sense. Our rating. So this is probably a rating out of 10. I would have to go check our like how IMDb does ratings. Probably rating out of 10. Vote count. This is how many votes were averaged together to get this episode rating. Also an IMDb thing. And then over here is a description of the episode itself. You notice the text trails off. This is another thing I love about Hex. So that you'll see over here when it populates your little table, it'll give you this preview version, which is just kind of simple. You can also toggle it over to display and it'll think for a second, and that'll give you a little bit more functionality here. So for example, you can change your column widths. If you want, you can sort of like drag it around a little bit like a spreadsheet. So you can see a little bit more detail. There's a way to make the rows taller, etc. So you can just do a little bit more like basic formatting in here. I could do things like sort if I wanted to sort by my ratings. Go sort descending. I want to see my top ones. You can just do a little bit of like quick manipulation here. This is helpful to just sort of like get your mind around what is this data. All right. Okay. That's our select star statements. The other type of query that you typically write when you first get a data set is you're going to do something called a count star. So count is sort of the simplest example in SQL of a function. So we did select star before, that's just all the rows. Count is just going to count how many rows there are. This sounds very simple, but this is something you always want to do with the data set to understand, is this hundreds of rows, thousands of rows, millions of rows? What am I working with here? So to do this, you're going to do select count and then parentheses star here from whatever your table name is. That'll give you our number of rows. So I'm going to hop back over to my Hex project. I'm going to add another SQL cell for this. So I'm going to come down, do my little stack of Oreos right here, and I'm going to do select count. Let's see, it highlights the words for me, so it gives me like a little heads up. Parentheses star from ratings data.
The first star
Goes right next to count. Yep. Yep. So for functions, the parentheses go right there. Yep. Okay, great. That's all I'm going to write for this query. And then I'm going to hit run, or I'm going to do command enter. I like keyboard shortcuts. Okay, boom. So this is going to give me just a 1 row answer, right? Instead of giving me a bunch of rows before I said give me 10 rows. This is just going to give me 1 row because it's just counting and it's just going to give me the count. So it's giving me 172. That means there's 172 rows in my entire ratings data set. Yeah.
Did we create a new SQL for that? It's not already in the previous SQL?
You could like overwrite it in this one if you want to. They're all very flexible, but to get it to show different results like the way that it shows this table and this table, to show those separately, you want a separate SQL cell.
So, if you were to write that on like the next line of the SQL, would it include the?
Yeah, I think it would just only show you one of them, but we can do a quick test to see how that works. In cases where you have multiple SQL lines together, which is somewhat uncommon, you're not usually going to have this. You do put a semicolon in between them, but normally you just do them in different cells. Let's see what this does. I think this, yeah, this will just only show you the results of the latest one. So I would recommend keeping them in separate cells. Cool. All right, so did everybody get a select star to show some data and a select count star to show a number? All right, did anyone do the transcripts data instead of the ratings data? No one went rogue. Okay, great. Well, we'll do one of those up here. Okay, so I'm just going to edit my one up here and just go to my transcripts data instead of my ratings data. I'm going to hit run. And let's take a look at our transcript data. Okay, so this data set looks a little different. So first it's got just sort of an unlabeled column that looks like a row number. I'm going to kind of ignore that. Next thing it's got is character name, Jerry George. If you've ever watched Seinfeld, this, you know that this data looks correct. Does that make sense? Dialogue. This is the line of dialogue that this character spoke in this particular moment. This is the episode number. This is giving SEID, SO1EO1. I'm gonna like use some context clues and figure that that's season 1, episode 1. I've also got my season number over here. Okay. All right, so this data set is a little different because you'll notice in our ratings data, we had season 1, episode 1, season 1, episode 2, right? That's how our rows look. Here, a bunch of these have season 1, episode 1. So what this data set actually is each row is an individual line of dialogue from that episode. So because of that, we're going to expect this data set to be much bigger, much smaller, much bigger, right, than our ratings data set. So to sort of validate that, make sure I'm correctly understanding what I'm looking at, I'm going to come down here and do my same thing. I'm going to do select count star from my transcripts data. Hex also does some nice like autocomplete stuff. So you'll see I started typing transcripts and it's sort of like suggesting to me, hey, I see you have a data table. I'm just going to hit tab to do that. And then I'm going to do run. Okay, my count star for this is 54,000 rows. Okay, that makes sense. We think about an entire run of a TV show. There's going to be lots and lots of dialogue. Makes sense. Okay. Everybody with me so far? I think someone over here came in a little bit late. If you just want to pop into this link, sign up. Yeah, okay. Go ahead, up there. Yep. Projects. Okay. All right, so written our first SQL query, or some of you had already written these before, but so these are the basics, right? This is the basics of how it works. Okay, let's get a little bit more in depth. Whew. Okay, so we talked about all this stuff a little bit, right? Once you have some results, you can go from between preview and display. Display just lets you do a little bit of sorting, a little bit more logic kind of stuff. We also will get into a little bit later the display and chart options, but you could create some kind of simple charts just based on your data set right away. Okay, and then once you have a chart, like I mentioned before, as you're working through your results, you can start to think about which of these cells would I want to include in my final result sort of report. So as I'm going through, probably these initial queries I wrote that are just like a sample of the rows or like a total number of rows, I probably don't need to include those in whatever final product I'm creating. But as we go through and write additional queries, you might start thinking about what I want to add to this view. If I want to add something to that view, I just hit my little icon over here, which says Add to App Builder. It's this little one that looks like kind of a quilt on the right. So if I click that on a cell and then I go back to my app builder, I see it pops up right here as a little table, which is pretty nifty. I don't want this one, so I'm gonna come over here and there's a way I can remove it. Let's see, remove from app builder. I'm gonna remove that one. Come back over here. Okay. Cool. All right. So what I like about SQL, what I mentioned before, is when the sort of question you think of in your head, it doesn't take too many steps to get to how would I write the SQL query, because the words are pretty similar. The way you construct it is pretty similar. So let's run through an example. Here's an example of a question we might have. What characters in Seinfeld speak the most often? Okay, if you've ever seen the show, you know it's probably Jerry, but you know, let's just double check. So which of our data sets is going to tell us which characters are speaking and have dialogue? It's going to be our transcripts data set. Yep, perfect. So I know I'm going to do from transcripts data. Okay, so let's go over. I'm going to grab a new stack of cookies here. Okay, so I know I'm going to want from transcripts data, so I'm going to type that part first. I often do this. Transcripts data. Okay, and then I'm going to come back to the beginning and add my select. Okay, so what am I going to select from transcripts data? So this is one of the reasons that you do your kind of select star, select count, so you kind of know what you're working with. So I'm going to go back up to my transcripts data and say, okay, if I want the character name, which column am I going to grab from here? Probably this one that says character. Yeah. Okay, great. So this is the name of our columns here, or the names of our like fields, if you will. This first one doesn't have a name, so it's actually showing up a little funky, but we have character, dialogue, etc. These little symbols here are just telling you the format of that column. So if it's these like little data type icons, I can actually like turn those on and off. So the A is actually not part of the name. Okay, but I know that my column is called character. So you can do a select star, see what all your columns are. That's how you can find out that I should put select character from transcripts data. Let's run that and see what we get. Okay. So I select character and I get Jerry, George, Claire, George. Okay, so I'm getting a bunch of things here. So if I asked you to list characters to me, you would probably not say Jerry multiple times, right? You would probably just say Jerry once. But if we look at this list, this is exactly the same as our column from our select star, right? So it's just copying that exact column. It's not doing anything like just pulling out unique values, anything like that. Yeah.
So for column name, like does capitalization matter for?
That's a good question. I believe it kind of depends on what your like source database is. I think for most, it should work without. I guess we can do a quick test. Let's see if it recognizes that or not. Boom. Yep. So for this one, not case sensitive there. So SQL can work with many different types of databases, and some of them can be a little bit different in between in terms of functions and stuff like that. So you may run into a type of SQL where that does matter, and this one it does not. Okay, cool. So we have our table names from here. Now you could imagine if your table has a ton of columns, it might be kind of annoying to like scroll to the right a bunch of times and see what they're all called. Hex has a nice little built-in thing for that. On this left-hand side, the little stack of cookies with a lightning bolt next to it is your data browser. That's going to tell you what all tables are available to you. We're working with data frames here because we've already imported our data. If you were going to set up like a new data connection to like some other service, it's got some like fancier stuff you can do. We're not going to worry about that for the purposes of this class. But if I click on my data frames, I can see all my data sources that I have in here so far. So let's click on transcript data, for example, and it's going to tell me what my columns are, and it's going to tell me a little bit of information about what type of data it is. So it'll say float, which is just another word for number. So I've got a number here. If it says object, that's more like a text. You'll start to like recognize those as you go through. And then same thing with my ratings data. I can come in and see it's got like integers, floats. Okay, so a few of these things are numbers. The rest of them are text. That kind of makes sense. So if I ever need to remember, oh yeah, does my column name have like an underscore in it, or like how exactly was it spelled or whatever, I can just come to my data browser and I could copy paste the name of my column so I get it exactly right.
Could you explain the like integers or object and floats?
Yeah, so integer and float are just different like numbers. It just kind of depends on how the database is storing them, but those are going to be numbers. And then object is going to be text or like a string of text.
You know, like what makes it displays integers, what makes it displays floats.
Yeah, so float's like a decimal, basically. For this data set, it doesn't really matter if like the season is like a float or an integer, because we're just going to use that it's one. But if you're working with scientific data or something, then that would matter a lot more. Okay, so we've got our query here of how, so the question we're trying to get to with this query is which characters talk the most on the TV show Seinfeld. So first thing we got to do is get a list of the characters. So we've got a list of characters here that are repeating. So we're going to add in one more little qualifier in SQL called distinct. I can spell distinct. So select distinct character from transcripts data. If I run that, so note that this one is just a modifier word. It's not a function, so there's a space. If I do that, then I see the results that I get. I only get Jerry once, I get George once, I get Claire, I get what's probably a typo of Claire, I get some other, so my data set is maybe not the most clean, but I see Kramer, Laura. Okay, so this are looking more accurate for what I would want for a list of characters. Okay. All right, so this is what we moved from, right? We started with just finding our table, finding our column. We've added this word distinct in here so we can filter down by what's unique. And then we want to know next how many lines, right? Which character is speaking next? We need to know how many lines, okay? So we already did something with how many rows, right? That was just when we did select count star of our total data set. So what we're going to do now is add a group by. Okay, so this is adding a basic summary. This is similar to a pivot table that you might do in Excel. So I'm going to group by character and then add in a count. So I'm going to select the character name and my count, and I'm going to tell it to group by the character. Okay, so what that's going to do is it's going to say, all right, I'm going to count up all the lines that Jerry says and spit out whatever number that is. I'm going to count up all the lines that George says, spit out that number next to George. So I'm essentially adding a column to this query that I already have here. All right, so when you're adding a column, you're going to put commas in between. So select distinct character, I'm adding a comma, and I'm going to do count star in my parentheses because it's a function. All right, if I try to just run this right now, which I'm going to do, I'm going to get an error. And it's going to say the column character must appear in the group by, because it doesn't know like what to count, like what would it put as the count? It doesn't quite know. This is actually a very helpful error message. So now all I do is come down here and I'm going to add our new keyword group by right here. And then I'm going to tell it character again. Okay. All right, so select character, count star from character data, group by character. Okay. Let's run that. Okay, this is looking pretty good, right? So now we have our same list as before, Jerry, George, Claire, typo of Claire. And then over here, we have our count column and we start to see, okay, big number for Jerry, 14,000 or whatever, 9,000 lines for George, and then smaller numbers for some of these other people. Yeah.
Why does it start at 0?
Yep, this is just a little kind of like index of the rows. It's kind of a common like coding thing to have the first row be 0. So not super meaningful. Yeah. Oh, sorry, here and then here.
This like the first query, there's a limit of 10. Then when you count the rows, it goes with like 54,000 more. But however, in the new query rows, there are just 10 numbers. So I was wondering, is it all connected or?
That is an excellent question. It is up to you, depending on what you put as the table name. So to answer that question, okay, so the question, in case everybody didn't hear it, was, all right, we did this query where we limited the transcript data to 10 rows. And then when we came down here and got the transcript data, it still has a bunch of rows. And like, why is that? That's because we're still going directly to the table itself, transcript data. So this query that we wrote before didn't save any changes to the transcript data table. And in fact, it spit out its own table, which is just labeled data frame. So if we go to our data frame, so if we go to our data browser just to see what columns are in there, it's got the same columns. But if we do a select from this data frame, which I can do here just as if it were its own table, I'm going to do select count star from data frame. Let's run that, and it's going to say 10 rows. So I can choose whether I want to reference my previous results or if I still want to reference the original table. Does that make sense? So if I came down here and did this query that we're working on, if I change this to be from data frame instead of my bigger table, only 3 of them speak at all. And then it's just going to do my summary on that level. So that's actually where the hex gets really powerful, because you can just have all these sort of like, I'm going to do this one transformation, this one transformation, this one transformation, and then later you can refer back to any of them or none of them, depending on what you want to do. Yeah, great question. Yeah.
I'm sorry, what is this? Why did we put distinct before character? What does that do?
Yeah, great question. So before we had distinct, when we just had, here, let me add another SQL thing back in here. So when we did select character, I can spell from transcripts data. So without the distinct, it's returning this, which is just the whole character column, just as is, regardless of whether it has repeats or not. And the reason we added the distinct is that we're trying to answer the question, which character speaks the most? And so from this list, like I'd have to export this, it's like 54,000 rows, and I'd have to like sort by, you know, alphabetically, and then figure out how many rows Jerry takes up and how many, and that would be annoying. I personally am not patient enough to do that. So that's why we added the distinct, so that we're kind of cutting this list down to the distinct ones. And then we run this now that we have it back on our other data source. Now it's going to do that counting for you as if you had like manually exported it to a spreadsheet, sorted it, and then counted the rows yourself. It's doing that for us right here.
So it's basically telling the program language that take Jerry as one distinct character and then count.
Exactly. Yep. Every time you see JERRY, add another one to this count, go through the whole list and do that. Do the next one. Every time you see George, add one to the count, go through and do that. Yeah, exactly. All right, cool. Okay. So we're getting a little closer to answering our question, right? So we have our characters, we have the number of lines that they speak. You can also add a little, just like for display purposes, any column you can rename with as. So I'm going to say number of lines. And then I'm going to run this again, just so it removes our little like count star. It gives it like a slightly clearer label. It's always nice to do, especially if you're going to be referring it to again in another cell. It's always nice to give it like a clear name. That's optional, but I'm going to do that here just for clarity. Okay, but we still want to know which character talks the most. Now, the order that these guys are appearing in here is actually the same as the order that it found them when it went through and tried to find the distinct, right? So here we've got Jerry, George. Jerry speaks more than George, so they're kind of in order. Then we got Claire, okay. But then we get down here, we get to Kramer, for example, who spoke a lot more than Kessler, but they're not in order, right? So I don't know yet who spoke the most, right? Because these aren't in order. Yeah.
Like if you put like as like line, it's the same as if you didn't put it, right?
Yep, the results are the same. It's the only thing that's changing is this little title right here.
Oh.
Yeah, just nice for like kind of following along, or if you're going to share your data with anyone. Nice. You either need to put underscores or you need to put it in quotes. So the other thing I could do is I could do quotes, and then I could do spaces. I could do number of lines like this, and then it'll do it without my underscores. So if you want to give it a multi-word name, you just got to do it in quotes. Okay. I kind of like my underscores because they're a little bit easier to refer to in code later. I don't have to type out my quotes again. So I'm just going to do that by habit, but you could do either. Okay, so we've got this, but they're not in order yet. So next thing that we need to do is order our data set, right? So if we go back to our sort of how to write a query thing, we've got our select, we've got our from, we've added a group by, right? We're counting by character, and now we're going to add an order by, so that you can think of this as sort of your menu of options to select from. Okay, so I'm going to come back over to my data. I'm going to do an order by. Again, you can do this on the same line. When my queries get longer, I tend to separate them out, but totally up to you. I'm going to say order by, but I don't want to order by character because I don't just want alphabetical characters. I want order by my number of lines. Okay, so I'm going to do that. Order by number of lines. If you didn't rename your column, if it's still just count star, you could also do order by 2, which will just order by the second column. So you can give it a column number or a column name here. I'm going to say number of. Yep, you can. All right. So let's do this. Okay, now I've got my characters, number of lines. Okay, it looks like it did order them, but it ordered them from lowest to highest, and I want them to go the other way. So it's labeled them ascending, right? Small to large. I want descending, which is large to small. So I can type DESC for descending after my order by. I can run this again and it'll just flip it upside down, right? It'll just flip from largest back down to smallest. So that if you needed to sort one ascending, it's ASC, much like one of these buildings, I think is called ASC. But that's the default, so you don't need to type that. That's just what it'll do. DESC will give you descending, which is this order. Okay. So getting to our question that we started with, which is what characters in Seinfeld speak the most often? This query, now that we've added a few things, gives us our answer, right? Our answer of fact was Jerry all along, not surprising. But then our next characters, George, Elaine, Kramer, Newman, those are all characters that are like pretty common recurring characters, main cast members on the show. So this makes sense, kind of gut check. And we can see our number of lines kind of going down from there. All right, so this process that we just went through where we started with a question, we kind of figured out like our table and our column, got a basic answer, sort of added one thing at a time until we got to our result. That's how I would recommend that you write SQL queries. That is still how I write SQL queries 10 years after I learned SQL. You want to write the sort of the simplest version with sort of the baseline that's going to start getting me some data back. And then I'll come in and add my group by, add my order by, add my where, kind of do that one step at a time. And with Hex, it's great. You can just like run it easily in between and make sure each sort of interim step makes sense to you, right? You can see if the character names are repeating. Oh, I don't want that in my final result. Okay, I'm going to need to add my distinct, etc. Make sense? Okay, awesome. Right. Okay, so this is the same query that we came up with, but I just say group by one, order by two, which are just the column numbers, same thing that we wrote earlier. Okay, so this is what I mentioned before about being able to find your data frames in Hex. So when I go into this one, so too many tabs. Okay, so every time that I run one of these cells in Hex, it's going to give me a little green thing down here, which will tell me the new table I've created. I can actually rename those if I want to. So for example, this one I can rename like top character. These got to have underscores in them, top characters. Great. So if you're like referring back to a lot of cells, as somebody asked about, you can do that. And then I could come see in my data frame later, oh yeah, what are my column names in this guy? Oh, it's character, number of lines. So these all become, every query you run, the results essentially becomes a potential new data source that you could use. So they're going to come up in your data browser. Does that make sense? Cool. All right. Okay. So now we're going to try a couple more queries. Let's just start with this first one here. So we want to figure out what season has the highest average episode rating. Okay, so like I said before, you want to start with the very, very simple pieces and sort of add to your query as you go. Okay, I'm going to give you a little hint and say that for here, there's another function that's just average parentheses instead of count parentheses that works the same way. Okay. So I'm going to answer a question about episode ratings. Which of my tables am I going to be selecting from to answer that? Ratings data. Great. Okay. So I already know, I'm just going to type select there. We don't know what we're selecting yet, but we know we want it from ratings data. Okay. What is the other information that I need? Which of the columns am I going to need to answer this question? What season has the highest episode rating? Season. Fantastic. Okay, so I'm going to select season from ratings data. Let's run that and see if that runs. Okay, great. We got a bunch of seasons. I'm going to look at my ratings data, and actually it's annoying to keep switching back and forth. So I'm actually going to copy paste this question into a little text cell in here. I'm just going to add some text, paste my little question right there just for my own little eyeballs reference. It's the type of thing that I recommend using this for. Okay, what season has the highest episode rating? Okay, season And what else might I want for my ratings data to figure out the average rating? Rating, fantastic. Okay, season rating from ratings data. Do a quick run. Okay, so far so good. Okay, so which season has the highest average episode rating? Okay, so next thing I need to do is figure out the average of the ratings. So I'm going to do that the same way I did my count. I'm going to do average. And then parentheses around my rating, not that I can type today, of course, or spell the word average. That's embarrassing. Okay, season average. All right, let's run that. See if that works. Oh, does not work. Okay, let's take a look. Scalar function. Oh, it's AVG. So it's AVG, not average. Okay, that's my typo. All right, season average rating. Okay, that also didn't work. Let's see. Column season must appear in the group by clause. All right, what clause do we think I should add? Group by, great idea. Okay, I'm gonna come in here, add a group by. And what am I gonna group by? Season, fabulous. Okay, select season average rating from ratings data, group by season. Let's run that and see what we got. Okay, this is looking better. Now I've got one row per season. And I've got sort of a different average number for each. These average numbers are like between 1 and 10. They sort of look like the numbers I saw when I did a select star. Great, always good to gut check at each step here. Okay, next thing I'm going to do is just give my little ratings column a cleaner name. So I'm going to call it average rating. Just to spell it out a little nicer. Okay. And then the last piece of information I need to add, what season has the highest average episode rating? So how would I order this? Order by average rating descending, very good. Okay, order by average rating descending, let's run that. Fantastic, okay. So I see that season 8 has the highest rating, kind of surprising, closely followed by season 7, and then kind of we go down from here. To use some like helpful hex features for this, I'm going to switch this over to a display from a preview, which is just going to give a little bit of a nicer visual. It also is going to allow me to do things like format my numbers. So for example, if I click on my average rating, instead of formatting it as text, I can format it as a number. And when I do that, it's going to round to 2 decimal places. So instead of being those long numbers, it's going to be like a nicely rounded number. So all I did there was switch the format from plain text, which was a bunch of numbers. I can change it. If it was a dollar amount, I could change it to currency, which is kind of nice, or percentage or whatever. I'm just going to go back to number. Maybe I only even want 1 decimal place. Click out of that, and I get this like nicely formatted little table. Okay. In fact, this table is so nicely formatted, I might want to add it to my final app, my final result. So I'm going to click my little icon there. Same deal on my little text just for fun. I'm going to add my little text to my app. And then I'm going to go over to my app, and now I have this pretty nifty little, like, this is starting to look like a report that I could send to my boss, right? This is like a very clean view. My boss doesn't know what SQL is, but we got this nice thing. Yeah. Yes. So all you do in here is make sure you change it to display from preview, and then you can click on your column and change the format. So it defaults most things to plain text. So I changed it to a number, and then you can change your decimal numbers down there. Cool. All right, did everybody get season 8 as your top rated season? Okay, great. It would actually be kind of hard to mess that up. Cool, unless you didn't get any results, that's a different thing. I can help troubleshoot if you didn't get any results. Okay. Yeah. Good question. Because first you got to change it to a number. Oh, yep. You got it. Very good. Okay, cool. How are we feeling about queries so far? Making sense? All right. Cool. Okay. Let's do another question. Let's do, what are the names of all the episodes in the highest rated season? What are the names of all the episodes in the highest rated season? Season 8, yes. This question over. To my notebook. So text thing. All right, who thinks they might know how to do this? Yeah, good. Take a stab at it. Give it a try. Yeah. We're gonna start simple, right? So your very simplest. What's the information that you need to start with? Yeah. Okay, how we doing? Anybody got a starting point for this one?
Select from Python.
Yep, so let's try that. So select from title. See what we get so far?
Move from ratings data and select its
Change data, select title. Okay, let's see what that spits back. Okay, we're getting some episode titles. This is good. All right.
How do you read?
How do we read season 8? That's a great question. Okay, so a couple ways we could do this. One thing is we need to know which column the season is in. So I'm going to go over here. Just called season. Okay, great. Let's go back over to our little menu of SQL options. Okay, so these are all the options that we could use to maybe manipulate further our results. So we only want season 8. So we want to sort of like limit by a criteria. So which of these might be? Where? Did someone say where? Someone said where. Where is correct? Okay, that was very stealth. I didn't know who said that. Okay, great. So I've got where. So I'm going to come down and add my where season. Okay, and what do I need to know about season? What's my criteria? Equals 8. All right, so I'm going to do equals 8. Let's give that a whirl. Okay, boom. Got a different list of episodes than I got before. Pretty cool. I could validate that this is correct in my brain if I wanted by adding season as another column I'm selecting. So I could just select title and season. And I could just see the number 8 show up a bunch of times just to sort of like check it in my brain. That makes sense? Okay, cool. I can also do my little display. The preview only ever shows you 10 rows. So if there's more, in this case, there's more than 10 episodes. So if I switch it over to display, I'll be able to see, all of my titles over there. Okay, very good. Any questions about this query? Good question. Why aren't we doing group by in this query? Anybody know why we're not doing group by in this query?
over.
Yes. Anybody know why we're not doing group by?
But they're all in the same group, like season 8, so it's just gonna repeat it, so there's no.
Yeah, exactly. So we're already selecting for season 8 and we don't need to like summarize further. So in this case, the information that we want is the name of each episode, which is already in each row. So the case where we would use group by is if we want to summarize information to sort of roll it up. For example, we could count the number of episodes in season 8 that have each title. So let's say I could do title and then count star from ratings data where season equals 8. And I need to do my group by down here. Let's add that as an example. And then it's going to tell me the title of each episode. And then it's going to tell me that it appears once in season 8. So these are kind of like, it's already sort of row level info. So I just don't need to summarize. Yeah, good question. Another little handy tip about SQL, if you're writing a query and you're kind of trying out different parts, this is a sort of a concept from coding. Let's say you wrote your group by and you weren't sure if you need it. You can comment it out by putting 2 dashes in front of any line. Will make it a comment. It means it won't do anything in your text, but it'll still be there in case you're like, I might need to add this in. I don't know, maybe I did it wrong. I can comment this out. I could run my query. Uh-oh, got an error. Oh, yeah, because I still have my count thing. Okay, I don't know if I need this count thing yet. We're gonna do a space and then do my 2 dashes. We'll do a comment. The comment makes the text gray, right? So it's there, but it's not doing anything. I can run this again, and it's just gonna do my query. It's only running select title from ratings data where season equals 8. So commenting is a great way to kind of troubleshoot if your query was working and then you add something and it wasn't working anymore. You can comment out the part you just added or part of what you just added and sort of be able to see what might be causing the issue. Does that make sense? If you've ever done any like HTML or tried Python or something like that, every coding language has sort of a comments thing like this, which is very handy. Okay, cool. Great. Okay. So let's talk about AI for a second. So when you guys all opened up Hex, you saw it has its little like Hex magic, use AI for this. That is one of the new options that they've added. Most technology platforms are adding something like this now, which you can use, right? You can use their AI. You can type in a question like, what is the top rated season of Seinfeld? And see what it gives back to you. It'll write some SQL or it can write Python. It can try a visualization to try to figure out what that is. When I was thinking about writing this sort of curriculum for this class, I was, doing Hex and I kept seeing the Hex magic and I was like, oh, we don't want to talk about that in class. But the reality is that it's here and you all are going to use it. And so I want you all to know how to use it and how to kind of work it into your workflow. Okay, so what you can do with this is ask it to write you a query and it will, right? It'll write you some SQL that like may or may not work in my experience. And you should treat that, if you're going to use that, as a first draft. So when I've used this, I've had it spit out a first draft. It usually gets some things wrong. And so I have to use kind of some critical thinking skills to look at what SQL it generated, what results it spit out, think about what I wanted it to do. And you can often just edit from what it gives you to a query that gets you what you want. But it's not going to give you the thing that works on the first try ever in the number of times that I've tried it. The technology is not there yet. I think it will probably be many more years until it's there. So if you're going to use this, you totally can. Feel free to do it in the class if you like. But you still need to know enough about how SQL queries work and are structured. And same thing with Python for next week, so that you can use it effectively, right? So I'm going to give you a couple examples that I was playing with this week in preparation for this class. Okay, so I gave it a very simple example in the world of like writing a good prompt for AI is like a whole nother, we're not going to go down that whole tangent. Okay, so I just wrote a very mediocre prompt. It says, which characters speak the most? Okay, that's a question I typed in just like that into Hex Magic, which is a type of cell you can add. Okay, what Magic did is it created a table because Hex can do Python, SQL, or visualization. So it just created this little like chart table thing for me off the bat. And if you squint down here, it does say Jerry, and this is a very long bar in a bar graph. And then there's a bunch of other little bars, and there's so many character names that they're all kind of compressed. So if you hover, the next one is George and Elaine, but then this one is like the 6th one. So did it answer my question? Like, yes, it did show me that Jerry speaks the most, but like this, I'm not going to put that in the report to my boss, right? Like that's not, no human would make that chart in response to this question, right? So that's not quite right. So we'll talk about this more later in the class, but there's some like kind of, this is just sort of clicking around in the data settings. I can like make the chart look different, similar if you've written a chart in Excel or PowerPoint or whatever. So it gave a result, it was okay, not great. Okay. Here's another one that I did. I got a little more specific. I said, write a SQL query for which character talks the most. I wanted to try to get it to generate some SQL. Here's what it did. Here's the query that it gave me. It said, select character, count star as line count. So it did a little renaming for me. It's kind of nice. From demos.movie data, I don't know what that is. Okay. Group by character, order by line count descending, limit 1. Okay. So that query is like kind of correct, or like parts of it seem correct, right? We just wrote this query a few minutes ago, right? Those character count, that sounds familiar, right? We see that it's doing the group by. Okay, we know that that's there because there's a count, and that'll give you an error without the group by. Okay, that makes sense. We know it's going to order by. We did that. It's doing descending, so it's the top one. It's doing a limit 1. Okay, you all have been learning SQL for the last 75 minutes. We can kind of understand what this query is doing, right? Makes sense? This query didn't run because analytics.demos does not exist. So this thing demos that was trying to draw some movie data from, like, it doesn't know what that is. It's not there. We don't know. So the SQL, it kind of looks right, but it's not returning any results. This is a pretty common outcome for using this AI thing. So I'm going to go to, so I took this. So once Hex generates some AI generated whatever, you can then go in and edit it as if you had just written it. So I clicked into this and I said, okay, let's get rid of that. Let's put in transcripts data. That's my table. I know that's my table. I did some select stars. I know that's the table this should be coming from. And then I hit run and it gave me Jerry 14,000 lines. That's what we found earlier when we just wrote this query using our human brains. That's what we found, right? We didn't do the limit 1. We just looked at the top row, but we could have added a limit 1. Okay, that sounds about right. That actually worked. That was a pretty like simple error. Now, but in order for me to know that this is what I wanted, I need to know what this table is. In order to know what that table is, I need to know how to like go do my select star, see what my columns are, right? So you still need to know some things in order to read this and make sure that you know that what it's giving back to you is actually what you wanted. My experience with this, I mean, AI has been around in like this sort of easily accessible format for like a few months at this point, right? It's pretty new. I write SQL every single day at my job. For me to do something like this, give it a prompt, have it spit something out that's kind of wrong, like fix it, that process versus like me writing a query myself, that's pretty like neck and neck for how much time it takes me. I've been writing SQL for a long time, so I can usually write it maybe even a little faster than I'm willing to like squint at what it did, figure it out, do some changes, whatever. So I still prefer to write them myself because that's just what I'm more familiar with. I'm faster at it. For you all, I mean, you're learning SQL in the world where this exists. So your experience is going to be totally different from mine. I encourage you to try it both ways, see what you like. The thing I want to like most encourage you all to do is when you do this, even if you may not get an error, it may run something, right? It may give you spit out some data, but it may not spit out the actual answer that you want. Right. So these tools are really far from being able to actually validate or debug or like get into the nuances of what we mean. And it might be related to human error, right? Like human like understanding, for example, the columns of my data set might not be labeled super clearly in a way that like the AI could understand what each column means. But I know that I came up with a little abbreviation for the ratings, whatever column, and I called it like RC for ratings column or something. Like the AI is not going to know that. It's going to get the column wrong. It's might average, the episode number or something. And it's going to give you like a season and a number or whatever, but it's not going to be quite right. That sort of result is very common. So if you're going to use this, feel free to do that today or in the rest of the class. But make sure you're looking really close and you can explain what it does. That's super important. Make sense? Okay, cool. If you want to do that in Hex down here, so we have our add SQL cell. It's just this first little one with the circles with magic. I think it makes you click OK a couple times the first time you do it. Okay.
All right. Okay, let's talk a little bit about joining data. So this is one of the core concepts of SQL. This is one of the reasons SQL is so powerful, because tasks like this are so annoying to do manually. Like if you're doing this in Excel with 2 spreadsheets and they have overlapping emails, oh my God, you got to do VLOOKUP. I mean, we just went through a whole class on Excel where we went through VLOOKUP. That's a whole thing. So this is an extremely powerful way, especially if you have big data sets. If you've ever been doing something in Excel and it crashes because you have too many things open, that's a good time to know that you need to move to SQL or something like this. Okay. All right. So for example, in our data set here, we have season and episode number in our ratings data, and we have season and episode number in our transcripts data. So those are some columns that we know overlap. Those are some pieces of information that we could use to join our data sets together. Okay. So we're going to kind of use this case study as an example to try out some different SQL functions. Okay, so the type of thing I might want to join my data for, why would I want to join my transcripts data to my ratings data? Let's say I have this hypothesis. I have this hypothesis that seasons or episodes that are more highly rated have more lines of dialogue from Elaine. Okay, that's my hypothesis. Right now, I don't have a great way to put those 2 pieces of data together because they're in different data sets. My transcript it's all by lines, and I need to figure out how to join them. Okay, so that's what we're going to do. That's going to be kind of our guiding question here. Is it true that higher rated episodes or seasons of Seinfeld have more lines from Elaine? Let's find out. Okay. So first thing we want to do is you can join on one column or multiple columns. Okay. So in this case, I want to join by episode. I'm going to say that my will hone in my question a little bit. My question is higher rated episodes and more lines of dialogue from Elaine. Is that true? Okay, so I'm going to look at my 2 data sets. Okay, my ratings data has season, title, air date, rating, vote count, description. Interesting. Okay, it's missing episode number. And if I go to my transcripts data, I have character, dialogue, episode number, season and episode number combined, and season. Okay. So if I want to be able to join this on episode, my ratings data is separated by episode, but only by title. It didn't actually give me the numbers. There's no column for episode number. Okay. So this is where SQL can do, this is where I was talking about, you can add on columns to your data. This is essentially a missing column in this data set. This is not fake. I did downloaded this data set from the internet and it was missing this column. So this is an actual problem that you might run into. Okay. So here's how I can fix that with SQL is I can give it some logic to add this column. Now, if I had this ratings data in a spreadsheet and I was missing the episode number column, what would you do? You have a bunch of rows for season 1, bunch of rows for season 2, and you needed episode number. What would you do? If I was just doing this manually, how would I go about doing that? Any ideas? Yeah, I would essentially go through for each one and I would say, all right, the earliest, the first episode in season 1, it's got my titles and dates. So I could do, let's do this. Let's do select star from ratings data. Ratings data. Oh my God. It's hard to type while people are watching. Okay. Ratings data. So these are season 1. I can see that they're already sorted by date in my source data set. So I would essentially just add a column and I'd type in 1, 2, 3, 4, 5, 6, right? That's how I would add episode number to this. We're going to do that programmatically with SQL so that we don't have to manually do that step. You could imagine you might manually do that in a spreadsheet, for example. Okay. So here is how we are going to tackle that. Okay. So you can add columns. So we did select stars. You can select all columns. Even though you selected all the columns, you can in fact add a comma and add more columns after that. Okay. So this is super powerful. So let's do this. So I'm going to say, all right, select star comma from ratings data, which means I'm going to make up another column to add. Okay. All right. So any of the functions that you can use to sort of add formulas, these are very similar if you've done any amount of Excel formulas. I know a couple of you were in the Excel class, or if you've used Excel otherwise, a lot of these are very similar. They're going to be very logical. Okay, so this is our final result. We're going to use a function called row number, which is just going to have it spit out the row number that we're at. Okay, so that's built in. We're going to use that. So I'm going to say select star and select row number. Nothing goes in the parentheses there because it doesn't take any arguments. It just gives us the row number. Here from, well, first, row number, do I have to do it in caps? Yeah.
For some reason, telling me that, reading data does not exist. After I press the imagine.
Okay, so it probably grabbed it from another source. So if you look in the upper right of your cell, if it doesn't say data frames, it might be trying to grab it from like a demo data.
Yeah.
Yeah, so if you just click that and switch it back to data frames. Yeah, that's exactly the type of thing that it's not very good at figuring out. Yeah. Okay, great. All right. Okay. So we're gonna do row number from our ratings data by season. Oh, I'm sorry, this was, let me go back to this. Why did you get unhappy with me? Mhm. All right. I don't know why that's unhappy with me. Okay, let's try this. Okay, so I was gonna try to show you the interim result. It's giving me an error and either I'm not seeing a typo or something. Okay, but I'm gonna use one more function to do this, which is going to be called partition. So partition is essentially just going to break it down by a specific column that I give it. So in this case, I want it to give me the row number, but I just want it to give me the row number within each season, right? I want it to do 1, 2, 3, 4, 5 for season 1. And then once it switches to season 2, I want it to start over again from 1, right? That's what this partition function is going to do. It's just going to apply what I'm giving it, which is row number over a certain range or a certain sort of criteria. Okay, so what this means, row number over partition by season, is it's going to give me the row number within each season. So pretty close, right, when I'm thinking about that in my mind, the wording here, like I said, it's like kind of like weird robot English, but it is sort of like comprehensible English to some extent, okay? So I'm going to come over here. I'm going to do over partition by season. Okay. From my ratings data, let's see if this is happier. Okay, great. Happier with me now. Okay, so now I have my same data set that I had before, right? I have season, title, air date, rating, quote, count, description. But now I have this new column, started with season 5 because I didn't give it a particular order and it's a computer, so just, you know, did a number first. It started with season 5 and it added episode 1, 2, 3, 4, 5. Awesome, right? That's exactly what I wanted it to do. I can gut check my dates and see, okay, September, October, November, right? So that everything's still in order. Those numbers are correct. Now I have episode number that I didn't have before. Okay. I don't really want my column to be called row number over partition by season. So I'm going to change the title. I'm just going to give it as episode number. And we'll run that guy. Okay, cleans it up a little bit, makes it a little nicer to read. Okay, so this is an example of a function that you can add, right? So if you have a set of given columns and you want to add a bunch more information, you can use a variety of SQL functions to add more columns after that. This is one example. There's a bunch of examples of these. We'll get more into them over the next couple weeks as well. But this is one example. Yeah. Okay, when you typed in this guy. Okay, that's fine. Did you get parentheses around your partition by season? Okay, and then do you have an open and close after row number?
Yeah.
Okay, what's your error message telling you?
Parser, error, syntax, error. Or near the parentheses of line 2.
Okay, so syntax error is usually like a typo type error. So if you get something like that, you might be looking at maybe you have an open parentheses but not a closed one, or you have an extra one somewhere. Okay, you're missing a comma. So select star comma when any kind of additional column, and then you need a comma. Okay, great. Partitions by. Oh, I think we have to take one partition. Partition, not like a ghost. That version. All right, anything else getting errors?
Okay, good. Yeah, anytime you see the word syntax error, that's probably some sort of like typo. So missing comma, missing parenthesis, misspelled word, that's all the stuff you should look for if you see syntax error.
Like in the previous ones, I don't think we put common, like.
Yeah, so the commas, so with the ones that we did before where we had multiple columns like called out, have commas in between. So that's where we got that concept from. This, I was just introducing the concept that you can do star and then comma to add more columns. So that's new information. But yeah, and so this can be a reason where like if you separate them out into multiple lines, it's harder to catch that error versus if I had them in the same line, I might have noticed that it was weird that there wasn't a comma. I don't know. So the new line thing, I find it helpful, may or may not be helpful, but that's the kind of thing you want to look for. Commas, parentheses, typos. Make sense? Okay, great. All right. So the reason we were doing this is because we want to be able to join our data sets about ratings and about number of lines. Okay, so we were missing the piece of information about episode number in our ratings data set, so we added that. Okay, so now I have essentially this new data set, and I'm actually going to order by season here just for my own. I don't know. I like things to be in order. I'm a data person. What can I say? Okay, I've got my stuff in order here, and this data frame 7. So this is essentially a new data set. This is the data set that I'm going to use to join to my my transcripts data. I'm not going to use ratings data in its raw form because I did the transformation I want already. Okay, so I'm going to just, you can refer to it as data frame 7. You start to have a lot of these, it's confusing. So I'm going to click in here and give it a different name. I'm going to double click, I can rename it. I'm just going to call it ratings with episodes. Did I spell that correctly? Once you rename, you do have to rerun your cell so it like generates the name. But once you do that, then I see it in my data browser here. And I see if I compare it to my ratings data, which had 6 columns, then this guy has 7 columns and it has my episode number and I can see that it's a number. Great. Yeah.
Is the exit number, is it automatically applied based on the order of the date?
Yes, great question. So yeah, so my data set just as in its raw form is already sorted by air date. So I didn't need to do an additional sort, but yeah, if your data wasn't in order to begin with, you would want to add, like you can add a sort by, I think it's if you do like partition, you can also add an order by within there to order it by the date. Mine was already, so I left that out. Yeah, great question. Cool. Okay, so I've got my new data source. I've got this guy. All right. So back to the concept of joining data. If we have 2 data sets that have columns with the same value, you can join them. Okay. So our season and episode numbers are what we're going to use. Now our transcript data has many rows per episode, right? It has a row in our data set for every single line. So each episode has probably, you know, I don't know what that is, that 1,000 lines, say. Maybe that's too long for half hour. I don't know. We could check. Okay. But my ratings data set just has 1 row per season and episode. So if I want to be able to join some information about each episode at the episode level across these 2 data sets, first thing I want to do is summarize my transcript data up to my episode level. Okay, so my original question for this inquiry is it the case that higher rated episodes have more lines from Elaine? So the summarization that I want to do in my transcript data set is for each episode, how many lines does Elaine have? Okay, that's the first thing I'm going to do. So how would we write that query? For each episode, how many lines does Elaine have? How would we get started writing that query?
Select.
Fantastic, select. You can type that every single time. Yes. All right. What else we got? How many lines does Elaine have? Which table are we going to be selecting from for this? Transcripts. Fantastic. So select from transcripts. Great. All right. This is usually how my queries start out, right? Then once I have this part, I might go to my data browser and remind myself in my brain what columns this table has. Okay. So what columns do you think I might want to use here? Character. Yes. Okay. Say again.
Equal to Elaine.
Yes, okay, great. So we are going to, when it's a criteria that I want to use, that's going to go under where. So I'm going to say where character equals. And then when you're doing equals text, the text is going to go in single quotes. You'll remember because they'll show up pink. So if I'm going to check what the text is, it'll show up. I want to put it in quotes. And I'm going to go up and make sure I know exactly how Elaine is spelled. So this is another reason that we did some of our exploratory queries before. I want to make sure I know, okay, it's in all caps. It's got an E on the end. I'm actually just going to copy paste it from here to make sure I don't have typos. Grab this down here. Okay, where character equals Elaine. All right, let's see if that runs. On a world. Okay. All right, we got a working query. This isn't super helpful format yet, but we're getting there. Okay, so yeah.
So does, Elaine need to be in all caps?
For this, yes, because it's matching based on text. You can actually test that out yourself if you want. Switch it to Elaine with lowercase. And it looks like there's one time in the script where it appears that way, but for the most part, it's going to be in all caps. All right, great. Okay.
Is there a way to like make it pull up all instances of Elaine, like without regarding compilation?
Yes, I think there's a function called lower, which translates everything to lowercase. And I think that's how you would do this. Yeah, so essentially what this is going to do is it's going to, before it goes and searches for Elaine, it'll put the thing it's looking, it'll shift everything to lowercase and then look. So that's one way that you could do it. Yep. Yeah, there's lower, there's upper. I think there's also proper. Maybe it's just lower and upper. Yeah, that's probably how I would do that.
So there's no way to put like both, all three of them into one table.
All three of what? Oh, yeah. So I could do that a different way. So I could say where character, instead of equals Elaine like this. How did I have it before? Elaine like this. I could also use in, and I could give it a list of things to go look for in parentheses. So I could give it Elaine. I could say Elaine spelled like this. Maybe there's Elaine without an E on the end. I could give it a bunch of whatever my options are. I could hit run and it'll give me anything that matches any of those different ones. Cool. All right, so I want to know by episode, how many lines does Elaine speak? So I got to do something else with my columns up here. So what else do I need to do with my columns? What other columns do I want to see here if I want to summarize by episode? Not a trick question. The column I need is episode number, right? I want to have my episode number up here so I can look at my data browser. I can see that my column is called episode number. I'm just going to copy paste that and paste that here. Remember, I got to do my commas in between my column names. So I'm going to do that. Okay, now I'm getting this. This is episode 1 from which season is this from? I don't know either what season that's from, so I better add season as a column. So I'm going to add one more column here. I'm going to add season, episode, character. Okay, great. All right, so the question I'm answering here is how many lines of dialogue does Elaine have in each episode? So what function have we talked about so far that would give me how many? Fantastic, count. Okay, so I'm going to do count. Count star, which will just give me the count of rows in my data set. Call this, just going to label this number of lines. Okay, let's run that. All right, column season does not appear in the group by clause. Looks like I forgot my group by. Okay. Helpful error message. I'm going to come here, add my group by, add season. Okay, great. Let's give that a whirl. I got an error again, very similar. Column episode number does not appear in the group by. Okay, so what's going on here? So we have 2 columns that we're sort of summarizing by before our count. So if it groups by season, it's still got a bunch of episode numbers. It doesn't know how to summarize by that. So I got to give it another thing to group by. So same deal. I'm going to give it episode number here. group by season and episode number. Okay, let's give that a whirl. Aha. Okay, now we're getting somewhere. Season 1, episode 1, 53 lines. Season 1, episode 2, 57 lines. Season 1, episode 3, 19 lines. Okay, so now that's starting to make sense to me. Right? I know Elaine's likely to have multiple lines per episode. That number kind of makes sense. That seems correct. And my data set is starting to only have 1 row per episode. Making sense so far? Okay, awesome. The other thing that's cool about SQL is there's a lot of ways to accomplish specific things, right? So in the question before about character name equals Elaine, or how do you deal with multiple capitalizations, we added a lower function, or we added this. All of those things will get you lines by Elaine, right? So there tend to be a few different ways that you can do things. Yeah, question about that.
Select season, episode number, and also character, but then the person we got rid of character.
Yep, because why do we get rid of character? In our final view, why did we get rid of character?
Oh, because like they're all the same.
We already filtered by the character, so we already know who the character is. We just don't need it in this view. We could have included it. We could have said season, episode. I could have put character in here as another column. And then I could have made it another group by column here. Oof. Let's run that. It's gonna think for a sec. And it's going to give me the same results that it gave me here, just with a column that says Elaine in between. Cool. All right. Yeah, here we go. So season 1, episode 1, Elaine 53, season 1, episode 2, Elaine 57. So same thing we got before. I just don't really need that column for this purpose, so I'm going to take it out. But there might be a case where you might want it, so you can include it. Okay, cool. So this is the query that we just wrote, got us this result. Now, I wrote another version of this earlier when I was preparing for this session, which is very similar to what we just wrote. So ignore this upper and lower part for a second. We're just going to look at these 5 lines right here. This gets us the same result as what we just wrote in a slightly different way. Okay, so just to give you an example of how of another SQL function we could have used. So I did select season, select episode number, same thing we did in my other query. I went ahead and relabeled it because I think it's weird that it did a capital N. I don't know, my own thing. Okay, then I use count. So similar to what we did before, you'll notice I don't have a where, right? So I didn't sort of do where character equals Elaine. I used a case statement inside my count where I basically did the same thing, right? If you read this in English, and you've never seen this function before in this class, case when character equals Elaine, then dialogue end. So I'm counting in the case when the character equals Elaine, count the dialogue as the number of Elaine lines. Okay, so from reading that in English, you don't have a ton of knowledge of what the case statement does, but does it make sense that that's kind of similar to our where character equals Elaine line that we had in our other query, right? Looks kind of similar. This is in fact doing the exact same thing as the query that we wrote. Super easy. So as you're kind of learning SQL, there's no, in most cases, not necessarily like a better reason to write it this way or to write it this way. So if, for example, if you use the magic assistant to try to answer this question, it might have written it this way, or it might have written sort of the case way, or there might be another way to write it that I'm not thinking of right now. So again, you might see things in different ways, but part of what you want to be able to do is sort of read and understand what it's doing enough to know whether your result is correct. The other thing that you can do when you see like a new function you don't know, when you're sort of at sort of like a kind of baseline level of knowledge, which I think is where you guys are probably trying to get based on this workshop. When you see this, if you don't know what this does, you can Google SQL case function and just get a quick explainer. There's a website that I like that I'll link at the end called SQL Bolt. You'll get to like some page like this that'll tell you what a case statement does. It's like a little like dry and not the most like exciting thing to read. But if you know enough about, okay, I know I probably need something character equals Elaine, right? Like that's kind of in your mind, then that might be enough for you to figure out that this gets you what you need. Make sense? Okay, one last note about this is when here we did count star, which is just counting like star is all the columns or like everything. Here I did count dialogue with my condition. So I essentially like moved my condition up, but what I'm counting is the dialogue. That's fine because in every single row of that data set, dialogue is not blank, it's like filled out. So count dialogue and count star are going to give me the same numbers for this data set. If you had a specific column that might be blank in certain cases that you didn't want to count, that's where you might use count that column instead of count star so that you would like not include your blanks. That make sense? Cool. Just to demonstrate that, I can add one more. Count dialogue. It's kind of quotes right now. It's kind of weird. Let's count dialogue. Let's just run that real quick, and you'll see it's giving me the same numbers. Yeah. And if you're ever not sure which one to use, you can do exactly what I did here. Do both. Compare them with your eyeballs. It's a good way to check. Do you want to be kind of like gut checking stuff like that at every step of using this sort of thing? Okay. All right. So this is my little query that we just wrote. There's what I'm doing here is sort of like putting a query in parentheses and then referring back to it again within the same little like hex cell. Okay, that's like something I've done here. For y'all's purposes, I'm going to write this again in a cell where it's just in a different cell, and I'm going to refer back to the one that we just wrote. Okay, so this is one here. This is my data frame 7. I'm going to rename this to Elaine lines. Run it again. Okay, so now I see in my data browser, I've got Elaine lines. Okay, and the next thing I want to do is my join, right? I want to, now I have season episode number of Elaine's lines, and I want to join it with my ratings data, which I have in my other data set. So that's what we're going to do now. Yeah, question.
Dialogue on them.
Yep. So I was just explaining that you can count either just like total number of rows in the data set, which is what count star is doing, or you can count the number of ones that aren't blank in a certain field. In this case, dialogue is not blank in any of these rows, and so the numbers are going to be the same. So I just add this column, count dialogue. So I'm doing count star, which is counting all my rows, and I'm doing count dialogue, which is counting all the rows where dialogue is not blank. In this case, I can compare these numbers, 53, 53, 57, 57, and just see that they're all the same. And this is a great case where we're going to like do that check, make sure it's the same. I might just add my 2 dashes to comment this out. I don't necessarily need it in my data set, but then I'll remember that I've checked it before. Use those for comments. Yeah, exactly. You can imagine if this was like an attendance sheet, you know, like who attended on this day, you would want to do count attendance instead of count star, because there might be days somebody was absent, that kind of thing. Yeah, question right here. Okay, cool. All right, so let's talk about joining. So I've got Elaine lines set up as this data set. I've got my ratings data, which already is formatted, my ratings with episodes, which is the other one that we did before. So I've sort of made myself 2 data sets that are all clean and ready to be joined. Okay, now when you're joining 2 sets of data, you can think of it as 2 spreadsheets, or maybe 2 spreadsheets printed out is the best way to think about it. So I've got my ratings, I've got my number of Elaine's lines. When you join, you can either join to the right or to the left. So you're essentially going to pick what is my main data set that I'm joining onto, and sort of, so which one's which is what you want to think about. Typically, you want your more, you want to start with your more complete data set, your one that has all your rows, and then you're going to want to join on. We're going to use what's called a left join, which just means I've got my one data set here, whatever I'm adding on, we'll just add on to those rows. So you want to start with your more complete data set. Now, just thinking about our data like conceptually, no technical background required. There might be some episodes where Elaine doesn't talk, right? There might be an episode where she was on vacation or, you know, whatever. So I don't want to have my starting data set be the number of lines that Elaine speaks, because I might be missing some episodes there. And then if I join my ratings data on, like, it might have some episodes where it doesn't join onto, so like it's going to skip those rows. Make sense? So I know that every single episode has a rating, so that's what I'm going to pick as my starting data set to join. So just conceptually, anytime you join data, just think about your like larger or more complete data set is typically what you want to start with. Okay. So with that in mind, I'm going to do select star from ratings with episodes, which is the version that I made before. Right. I can just double check that this one has my episode number. Okay. All right. So then we're going to do a join. Typically in practice, there are like several different types of join: inner join, outer join, right join, regular, like there's a bunch of joins. In practice, I would recommend mainly using left join. This is like the main thing that you'll use in real life. If you're going to do like a basic join and know a little bit of SQL, I would go with left join. Okay, because that's going to get you this concept of what are all the rows that I picked from my first table, and then whatever my second table is, anywhere that the information matches, just add those on. Okay, so I want to left join my other table. So I'm going to do my Elaine lines, and then I got to tell it how to join them, right? It doesn't know which of these columns are columns that are going to join on. So what are my columns that are going to tell me which rows match with which? Or what are my columns that are the same between these two data sets? Maybe it's a better way to phrase that question. Season and episode. Beautiful. So we're going to use the keyword using here. So left join Elaine lines using, we're going to give it some parentheses, and we can give it one or more columns. So in my example earlier, when we were talking about joining on email address, it would just be using email. That would just be it. We're joining on two columns here. So I'm going to do season and episode. Okay, great. Let's give that a whirl. Okay, error. All right. The error is that column episode number does not exist on the right side of the join. Okay. So the first thing when I'm using my left join, so that our ratings of episode is on the left, which means our Elaine lines is the thing we're adding in on the right, right? Like you could think in Excel and like adding more columns. Okay, so basically what this is saying is episode number does not exist on the right side of the join. Huh, that's kind of weird. We know episode number exists in this data set because I can see episode number. But column episode underscore number does not exist. Here it's called episode NO. Okay, so in order for the sort of using statement to work, my column names have to match exactly as well as the values. So how do I fix my column name? You remember how to change my column name? As, great. Then I'm just gonna make sure I spell it the same way, episode number. Okay, and then this is the great thing about hex. So I'm gonna rerun this cell. When it reruns the cell, it's going to automatically rerun any downstream cells, so cells that depend on this cell based on any changes I've made. So I'm going to run this, and you'll see they both did the little loading icon, and this one changed down here, this cell, even though I just edited the upstream cell, right? I edited it up here, but this one changed because I changed the data source it was pulling from. Okay. So we're changing the column name here to be spelled the same way that it's spelled in my ratings data set, where it's episode underscore number. And here it was episode no. So we got to make it as episode number in order for this, or using like list of columns, it's got to be spelled the same way for it to match. Okay. All right, let's take a look at the results that we got here. Okay, so select star, meaning it's selecting all columns. And because I'm joining, it's selecting all columns from both of these tables. Okay, so star is covering across both tables. So I've got 7 columns in my ratings table. I've got 1, 2, 3, 4, 5, 6, 7. Okay, those 7 columns are showing up here. That all looks the same. And now I've got an additional column called number of lines over here, which is coming from my Elaine lines table that I made right here. Okay, now you'll notice Elaine lines has 3 columns. Our result just has these 7 plus 1, but it's not going to copy these columns that we're telling it are the same, right? That makes sense. We're saying season and episode number are going to match. They have the same title, so it's only going to surface them to us here once. Okay, yeah, question.
I'm still having the column numbers left side of
On the left side of the join. Okay, so left side of the join means it's your ratings with episodes. That's our left-hand side. So you want to look in your data browser and see what you called your column in whatever data frame has your ratings with episodes. So remember, our original ratings data didn't have episodes, and we previously wrote a query that added episode number as a column. So you want to make sure you're referencing that data frame, whatever that's called. Yeah, so this is, so you have to scroll, and then once you find it, I might recommend renaming it. That's why I like to name them so that I can go back and find them easier in the data browser. Yeah.
But I have it like named. Or where does scroll to see how I named it?
You should be able to go in your data browser. So
You should, yeah, right, so you call the episode number, it looks like it has a space. Oh. So I would recommend going back to that query. Oh. Or search for what you. Thank you. Cool.
all right. Just another little hex navigation tip. This little outline option in the upper left. This will just gives you like a quick version of each cell on the left, so you can scroll through and find your stuff. Okay. Awesome. Okay, so we covered a lot today. We'll do a little bit more of this in the future sessions of this, if you want to come back. But if you want to just think about how you might do this last bit. So how would you add columns to, so we had our season episode number of lines by Elaine. How would you add a column that has number of lines by Jerry, number of lines by George, number of lines by Kramer? All I would do is I'd come back to my Elaine lines query that I had right here. And I could write another query that is basically this, but where character equals Jerry, or where character in Jerry, right? I could do that in another cell. Or if I were going to do a case like this, thing like this, I could add a comma, basically do this again, count case when character equals Jerry, then dialogue end, or then star end as number of Jerry lines. Right, so once you have a basic SQL query, going back and editing or adding another similar column, it's pretty straightforward. Okay, you just got to think about which spots you got to swap out. Okay.
So in terms of writing,
Yeah.
I need to like where character equals to George, or can I just write Elaine, comma, George, comma,
Yeah, so you have to tell it character because it's not going to know which column to look for the information. Elaine, George, Jerry. Yeah, think of it as like a very like literal human. Like you have to tell it, you know. All right, great. Cool. We already did where clauses. All right, so we covered a lot today. Okay, just to like go back to our little summary from the beginning, which if I were good at slides, I would have totally copied again at the end. Okay, so we talked about kind of all of these portions of writing a query, right? We know we can write a bunch of queries with just select and from. We did that. Select column name, select star, select count, right, from our tables. And then we did a bunch of different combinations of these, what are these 5 options? Join, where, group by, order by, limit, right? We played with all of those. So in the last 2 hours, you've learned how to write a whole bunch of different types of SQL queries using this as kind of your menu of options. Okay, so it might not be super automatic yet. It might not seem super like, okay, how do I go from my question to my query? That's probably going to take you a little bit of time. You can use an AI assistant or kind of magic thing to get you started. It'll give you a basic like select from where type of thing, and you can edit from there. But this is kind of your menu of options. You know how to at least understand, draft a query that's using these types of things, which is pretty awesome. That's pretty cool. This is why I like SQL as a programming language for kind of getting started. If you haven't done a ton of programming before, because you can't get this far in 2 hours in almost any other programming language. It's pretty cool. Good stuff. All right, so what I will leave you with is in this series, so Monday nights in April, we're going to have 3 more of these sessions. So our next session will be an intro to Python. We're going to be using Hex. And what we're going to do is very similar to what we did today. Kind of write bits of Python, see what it spits out, write bits of Python, see what it spits out. We'll actually also start interspersing it in week 3 with some SQL. So we'll write some SQL to get our data how we want. Then we'll write some Python to manipulate that data further, or maybe visualize it, whatever. We might write some more SQL after that, just depending on what we want to do. So that's kind of how, so we'll use Hex throughout this little workshop series. And then in the last week, we'll talk more about the visualization options. It has some built-in stuff in there. That's a little bit easier to play with by yourself. If you want to start messing around with it, you can. But that's in there. So that's kind of our whole series. If you want to kind of find any resources for continuing to learn yourself, hex.tech is the website for this Hex platform that we're using. They have a lot of great tutorials and just little help docs on their website, which is learn.hex.tech. So you can grab stuff there. There's a really great mystery.nightlab.com is a really fun like SQL tutorial that's murder mystery themed. It's a lot more fun than the average internet self-guided tutorial. So if you're into that sort of thing, I would recommend that. And then there's a bunch of websites. SQLbolt.com is one that's just sort of the more standard, like what are all the things you can do in SQL. So those would be some other things to check out. All right, that's all I got for today. I think we're just about right at time. So thank you all so much for coming. I really appreciate it. It's great to see so many faces in here. And I love when folks are kind of getting their toes wet in this stuff for the first time. So thanks for coming. I hope you come back next week. Even if you're not sure if you want to learn Python, come on by. It's worth knowing at least a little bit about how it works. I'm going to stay up here for a few more minutes if you have questions or want to chat. Come on up. Cool. Thanks so much. Oh yeah, it's all saved in there, so you can go back. You can use Hex in between classes. You can create a new project and like try some of your own data sets. Feel free to muck around. Yeah. Yeah, it's a Zoom. Actually, I need to stop it. Thank you for reminding me. I think these get posted on